Hi, so I'm John. I've been teaching at Berkeley for quite a while now, but we started kicking off an initiative to teach data science um, back in 2015, launched some new courses, and our particular take on how we would introduce data science into the college curriculum was to focus on undergraduates and try to think of it as a way of kind of exploring whatever intellectual discipline, using data, using computation, using statistical inference as tools for understanding other domains in the world. And that it was something that students could start working on the day they showed up on campus. And yeah, so first we built the freshman course. I'll tell you a little bit about that today. Then we built some follow-on courses because the students who took the freshman course wanted something else to take. I'll tell you about one of those today. And then we built a major because there were students who were wondering, kind of, can I just do lots and lots of this? So the major is brand new. We just started admitting students this academic year. And I thought I'd tell you a little bit about how we structured it, what the courses were that we had to build in order for it to exist. And then we'll actually dive into some of the example lab assignments for these courses so you can get just a little flavor of what the students are doing around here. But hopefully I'll get some questions from you all so that I can figure out what to talk about, because I can ramble on for a long time, but I'd much rather hear what you're interested in. So we'll start with, like, what is this data science major, because it tells you why all the different courses exist, but then we'll talk about some of the courses. Slides aren't behaving. Okay. Well, here's something. Okay, so I hope you all can see this. This is like an image of the data science major. And no one's telling me on chat that they can't see it, so that's good. So we built this freshman course called Data 8 Foundations of Data Science, which is really a replacement for the introductory statistics course we had on campus. In this version, we teach people a little bit about how to program, and then we kind of walk through many of the standard concepts in an introductory statistics course, but using computation as a lens, or as I like to say colloquially, assuming computers exist instead of assuming that they don't exist. So, so we'll take advantage of computation whenever we can to load data, work with data, and actually we kind of focus on sampling techniques as a way of understanding statistical inference, with the hope that that makes things more intuitive and gives them something to kind of practice their programming skills on. So they take this course, and then we debated a lot whether we needed like follow-on courses for this, whether there should be an intro series, but eventually concluded that the courses we had on campus were sufficient to build upon what we had introduced in Data 8 in order to get them to a level where they could kind of go into more detail, deal with kind of the more subtle issues that arise in data science at the upper division level. They take a couple of programming courses, they take calculus, they take linear algebra, and only after they've done all that do they take another data science course, and that's Data 100, which is Principles and Techniques of Data Science. I'm teaching it for the first time this semester, so I know a lot about the beginning of it because the semester just started. I'm still kind of working my way through the material. It was designed by some other folks I'll tell you about. But this Data 100 course is meant to be a course that really gets students deep into the data science lifecycle, understanding what issues and pitfalls might arise, how to use standard tools, and gives them practice on kind of like larger problems with a larger scope, and kind of more mature view of understanding uncertainty and interpreting the results of either prediction or statistical inference. But this isn't kind of, this could be an end goal to take Data 100, now you kind of know how to do things. But then there's also quite a bit of more specific depth that you could get. So the structure of the major is that the kind of core courses continue after Data 100 with a specially designed probability course I'll tell you a little bit about today, and then a course that we're currently designing about modeling, learning, and decision making, which will be kind of the course on the standard path through our data science major that introduces kind of machine learning and inference to these students. Now, there's machine learning elements all the way since the freshman year, but of course you have to revisit these concepts many times in order to build a good understanding. And it's not until this last course that students have a strong upper division understanding of probability, and so they can kind of mix together the empirical and theoretical perspectives in a way that we'd like them to do. So that's kind of the backbone of the major, is 4 different courses. I guess that's the technical backbone of the major, is these 4 different courses, 3 of which exist already, 2 of which I'll tell you a lot about today. And then we are building a bunch of other courses as well. So if you look at the structure of this major, over on the left, there's something called computational and inferential depth. Mostly those are courses that existed on campus already. If you want to learn about time series from the statistics department or databases from the computer science department, you take one of those courses. There are some new courses that are popping up, just like, but not built for the major. They're just because, faculty are finding new ways to teach about this discipline. And over on the right, we do have a brand new course called Human Context and Ethics of Data, which I admit I don't know as much about as I would like, but I really love the professor who's teaching it, Catherine Carson. So I'm really excited about what's going to go in there. And this is kind of talking about all of the ethical challenges, the social implications of using data, collecting data, and making decisions based on data. So that's a course that we built for the major. And then the domain emphasis is where students apply what they're learning in data science courses to some domain discipline. So there's the most popular track is in cognition, where students kind of think about topics in cognitive psychology, but there's also a domain emphasis in economics, where students are thinking about kind of modeling and simulation in economic applications. And then there's some people doing sort of applied math work, but there's a long range of domain emphases. And if you want to know all the details, well, there's a pretty nice website now. Just flash it up here, and then you can look at it on your own time. Data.berkeley.edu, which describes the organizational unit on campus that's trying to manage all of this process. And you'll see here that the major, which is now available, has that same picture I showed you, and can tell you about all the different courses in some detail, like what are the requirements and what counts in each category. And some like reasonable thought has gone into exactly what counts as a computational and inferential depth course. So if you're curious, I'm happy to answer questions, but it's all also public there if you're interested in what it takes to be a data science major at Berkeley. And it turns out some students are interested. So we began taking declarations just this academic year, and we already have 323 students who were declared. I think about 100 of them will graduate this year because they have been working toward something data science major-like for their entire time at Berkeley, and they happen to just need a couple more courses in order to fulfill the degree requirements. So this is something that's live and happening now.
John,
Take some questions. Somebody started to talk and then got muted.
John, can you say more about how the domain emphasis is worked into a student's data science major?
Yeah, sure. So a domain emphasis is 3 courses. Many of these courses existed already, but it's often the case that new courses built with the kind of prerequisites of these new data science courses are popping up and being included in the domain emphasis options. And so the story is that while you're in the lower division, you take a lower division course in economics. Maybe it's just Econ 1 to give you a sense of what is this domain. And then when you're in the upper division, you take 2 more upper division courses that are where we've picked out courses that have a computational or statistical inference aspect to them or in some other way seem to relate to the notion of data science. And so you take a couple of courses, which are sometimes in the econ department, sometimes they're offered by the business school. So it's not really like a strict matching from department to domain emphasis, but something that's kind of 3 courses that are intellectually coherent and teach you something about the world so that you can apply data science to that.
But it's not coordinated with any of the faculty in data science.
It doesn't have to be, well, yeah, so data science doesn't have its own set of faculty. Instead, it's really a broad set of folks that are participating. Let me just poke around for a moment to show you some examples. Every time we try to develop new domain emphasis, we do it in consultation with the relevant departments. So it turns out like basically everything that ended up on the list of econ courses that would count toward the economics domain emphasis are from the economics department, although there is an environmental economics department that's sort of different, and we talked to them and said, do you have anything that that would naturally fit into the data science major as part of an emphasis? And for these courses to appear on this list, the folks that teach those courses have to agree that yes, you can send your data science students this way, and that this is kind of the right subset from which students should pick concentration.
Great, thank you.
Okay. Someone asked, I'm from India, and how can I come here? So I'm talking about undergraduate programs, so you can, apply to our undergraduate program, but it sounds like you're already long past that. We do make all of our course materials available online. So everything I'm going to show you, you could just work through at your own pace. And then there are graduate programs across campus that relate to this. I guess I could touch on them a little bit at the end. Okay, so that's the gist of what we've built, and people are doing it. I'll tell you about a few courses, and you can ask me questions about the courses. So Data 8 we built first. It's now on track to become the largest course on campus. I think it's not quite the largest. I think there's one more that's larger, which is our second semester computer science course. But the rate of growth is astounding. So it certainly is going to become the largest course on campus. Right now there's 1,500 students enrolled, and this is meant to be something that anyone could take regardless of their background, as long as they have an algebra background. The truth is that students often are looking for some prior experience in statistics and or computer science in order to have this course be at a more comfortable pace. If you really come in with no background, then it moves pretty fast. But it's not designed to move so fast that it's unattainable. We do have lots of students who come in with kind of no prior experience and do fine in the course. And we teach them to program for a few weeks, but the subset of programming that we pick is very narrow to just focus on the concepts you need in order to kind of work with data and talk a little bit about statistical inference. And then we spend most of the course talking about some of the core ideas that you'd expect in a kind of intro college level statistics course, or there's a high overlap with what you'd see in AP statistics at the high school level. So yes, we're talking about hypothesis testing, confidence intervals, and kind of estimation in general. But then there's a part that's a little bit different, which is at the end, we talk about prediction. And there we talk about what's a classifier, how might it work, what's kind of a data-driven program. We teach them about the k-nearest neighbors algorithm for performing supervised classification. And they go use that in order to try to predict the genre of a movie based on the script. So it's an exercise that I don't think would typically show up in an intro statistics course. Data 100, I mentioned before, is also huge. I think it's the largest upper division course on campus now. We have 949 students enrolled, and there are some graduate students enrolled in the course. Through a master's in engineering program, we get several. And then we also get, master's and PhD students from around campus. who are interested in figuring out how to fit data science into whatever else they're learning. So this requires data 8, but then it also requires them to go take the intro computer science course. It's kind of like a rigorous introduction to programming and structuring programs. And they're supposed to go into the math department and take some calculus, take some linear algebra. A lot of the themes that show up in data 8 also show up in 100. So both courses are kind of organized around exploring data with data visualization, kind of like quantifying your uncertainty about your conclusions using statistical inference, and making predictions about things you don't know but you wish you knew using some kind of machine learning. But in data 8, it's only k-nearest neighbors. In data 100, we're doing logistic regression and multiple regression and random forests. So it's kind of just like in data 8, we choose the way in which we illustrate these themes very carefully to be something that you could digest even if you just showed up on campus. And in data 100, we try to focus on the tools that people actually use in the world, with the expectation that students have been thinking about these ideas already for a couple of years, and so they're kind of ready to hear about some of the more sophisticated ideas. We built a new probability for data science course. Okay, that's a lie. We didn't build it. One person built it. If you know Ani Athakari, who's been in the statistics department here for some time, she and I put together the first version of data 8. And she said, like, I love the way we're teaching this, so I want to redesign the way we teach upper division probability, and kind of just did it on her own. It now has 200 and some students enrolled, so it's growing fast as well. And it's an upper division course, so it requires that you've already taken a statistics course like data 8, linear algebra course, and a calculus course. And it really is just the classical probability course topics that you would expect to see, where they study different distributions and expectations and things like Poissonization. But they illustrate all these ideas with computation. So there's like extra exercises that involve sampling. And I wouldn't say like works with real data. Instead, it's really just about the theory. But sometimes the theory can be explored using a computational process in a way that can be helpful for students. And the Human Context and Ethics of Data course is also huge. It's got 230 students in it. And this, we really do try to introduce some social questions as we're teaching data 8, data 100, because they naturally arise in the context of working with certain data sets. But we don't really get a chance to work through the issues or write about them. So that's why this additional course exists, which is a required part of the major. And the minor that we're developing, I think, will require it too. And so that's just like a way for students to think about, what's the impact of what they're doing.
John, a question came out from the chat room that I think is great. This was regarding data 8. Have you heard from other universities about how well matched the level of courses to first-year unselected undergraduates? And a comment is added that the data 8 course is much too fast for my students, selected undergraduates from Birmingham University.
Yeah, we've heard this feedback and several times. So the pace of data 8 seems to push students around here. And so I think most of the students around here are taking it as kind of one of the core courses that they focus most of their attention on. So it's not something that fits nicely into a schedule as kind of just like an interest course on the side. It's also the case that we have just a tremendous amount of support structure around the data 8 course, so that if the course is moving too fast, students know where to go to get help. And the help comes from more senior undergraduates who have taken the course before, who are now there as course tutors and course teaching assistants. And office hours are full all the time with students dropping in because they need help. So it's really not a course that that our population could work their way through without some kind of support mechanism. I know that several other universities have tried to launch a variant of this course. If you're on a quarter system, it seems like the right thing to do is just to split it up over 2 quarters. and give the students more time to digest it. In a semester system, it might make sense just to prune some of the material in order to kind of improve the pace, I would say. And yeah, I think among the courses we have on campus, it is certainly not the most extreme in terms of asking a lot of students, but it is quite a rigorous course that tries to cover a lot of material. I mean, you can just see from this one bullet point. If it's supposed to be a full introduction to statistics and teach you how to program, then there's a lot of material in the course. And so like a natural thing might be to split it up over 2 quarters or maybe even 2 semesters.
Can I follow up on that? I was the author of that question.
Yeah, sure.
Yeah, so I mean, it's basically, you said, teach them the elements of programming in 3 weeks. And do you know Peter Norvig? I'm sure you do know Peter Norvig's Learn Programming in 10 Years website. Yeah, I've kind of stopped pointing students to that because, I mean, it basically, things like, sort of for loops and functions and things, I can't do that in 3 weeks or anything close to it. I mean, I guess if I could persuade them to do a lot of homework, I could maybe get that done in maybe half a term here. We have 3-term systems, but the consequence is that basically I'm not teaching very much about data. I'm teaching much more about programming.
Yeah, I guess the way we do it is that we're just extremely aggressive about pruning programming topics so that they don't really know how to program in general by the end of the course. Instead, they know what compound expressions are, and they know something about functions, although they don't know everything there is to know about what a function is.
Yeah, no, I'm teaching what you're teaching. I mean, your textbook's great, and I'm following it sort of fairly closely. But so for example, for loops. I mean, I had a set of people just sort of staring at me when I introduced for loops. That's completely nonsensical to them.
Yeah, that one doesn't go over easily among anyone, and I think. Yeah, I mean, there's a trade-off where if you want them to kind of master for loops, then obviously you can't teach all this other stuff at the same time. If you, well, but I mean, if like the way we teach them to write for statements in Data 8 is basically through a templated approach, which says, you want to do something k times, here's what it looks like. Don't worry about the details, because the details will come in the following course on programming. Because they kind of all feed into the intro computer science course after that. But yeah, that there's a tension there that I am nervous about as well, which is like what happens if they ask for more information, and it's obviously uncomfortable to tell them, look, well, just wait till the next course. And then what if they really do need more information because of the misunderstandings they have? That's tricky too.
Well, it's also, we're kind of saying, you really need to sort of properly understand data and be skeptical. And then we're sort of saying, but take my word for it, you should do it like this type thing, which is quite a hard sell.
That's true. I think, I think this course was built to fit into our curriculum, which is that we have an introductory computer science course that was built for people with prior experience, but no particular prior experience. So students do well. So this is a course called CS61A. It's based on the old MIT curriculum of structure and interpretation of computer programs. And we know students don't do well in that course if they have no prior experience. But but a particular course, like having taken AP computer science or having taken like a particular prep course on campus, doesn't seem to matter much as long as you have some exposure to what it is to evaluate expressions and to write down what a function definition. So our hope was that the Data 8 would give students that kind of exposure, but maybe not give them a whole lot of understanding about the programming structures, because we knew they were going to kind of jump into that material in the next semester.
I mean, the only reason I mention it is because that was, when I first arrived here, I was kind of saying, students can understand, statistics and data much better if they use some coding. And, the very experienced teacher sort of looked at me blankly and said, you'll never get away with that, Matthew. And, of course, the answer is you can, it's hard to get away with. I mean, you can get away with it. I'm sure it's worthwhile, but it's a hard sell to the university, I think.
Yeah. Um, right. Well, we haven't run a lot of controlled experiments on this, so I can't tell you for sure, right? There's plenty of anecdotal evidence that students um, seem to pick up some like intuitions about what happens when you sample because they have the ability to take a sample from any distribution they have their hands on, and then they also have a way to visualize it easily, and so they can kind of like sample a bunch of times and look at what happens. I think that does build understanding, but you have to set them up to do that either by just giving them a tool that does it for them, or by giving them a programming environment where it's relatively easy. We chose the second one, but yeah, there is the overhead of trying to get them to be productive in that programming environment. When we teach this course, we teach it with a 2-hour lab every week. And in that lab, we have multiple instructors kind of wandering around, staring over students' shoulders, making sure that they're kind of writing their first expressions right. And I couldn't imagine that students would pick up the programming without that. So, so maybe if it's not working, there's something about kind of how you staff the hands-on parts of the course that might help move the needle a little bit. Okay, well, I'd love to hear more, but maybe we'll keep marching forward. Yeah, so this is a challenge in Data 8, and Data 100 is less of a challenge because they've already taken a couple of programming courses. When students are taking the freshman course, they are often taking another course called the connector course, and here's like a little poster that someone put together about all the different connector courses on campus. And these are 2-unit seminars taught by faculty from the discipline that the course is about, that are trying to show students how computation and statistical inference are relevant to different fields. So kind of showing data-driven work in cognitive neuroscience, or in childhood development, or in cancer research, or whatever. So, so this is the kind of thing that sprung up because we have lots of people on campus who are doing this kind of research, and they were interested in sharing that with undergraduates. I won't talk about any of these in detail unless you all have questions. So, yeah, Matthew's here teaching this course, so he can tell us more about it as well. But here's what we're offering here. This is a freshman level course where we were giving them this like very narrow introduction to programming, where really they're just working with tables of data. They kind of learn the relational format of like, oh, there's named columns and there's rows that have some order, and they learn the basic operations of sorting and filtering and joining and grouping. And that's really all the programming we want them to learn. In addition, we ask them to learn how to write a for loop just to do something n times. But the only thing we really have them do with it is sample or resample n times from some distribution, and then compute some statistic from the sample and then record that. So it's pretty kind of formulaic and narrow version of iteration that they get in this course. Whereas like any intro computer science course that would really try to teach this fully would have like nested for loops, and we never see that anywhere in this course. The goal was that we could express in code what we otherwise might have expressed in equations. So yeah, so instead of like writing out a summation, we're always just calling sum on some array or some list. We basically don't talk much at all about asymptotic assumptions or approximations, and instead we just perform simulation in order to perform statistical inference. And then we're really interested in real world data and kind of pulling a data set from the web. Now in this course, we only pick ones that are cleaned up by us or were cleaned to begin with. So they never see a missing value in Data 8. I hope that's true. It might not always be true, but they basically don't confront the issue of what you do about missing data. in Data 8. They spend very little time like formatting their visualizations. Instead, they just need to know like which visualization to generate from which column of the data. But we try to kind of hide the complexity of figuring out like how to get the programming environment to label the right axis in the right way, and instead try to do it for them. And then we spend a lot of time on visualizations. So I mean, I think that's one of the main advantages of working in a computational environment, is that instead of just like computing the mean, you just look at the distribution, and that can tell you things that you might have missed if you only looked at a couple of statistics describing a sample. And we basically don't talk about models when we're doing statistical inference, but instead just data-driven sampling procedures. And we get people from majors all around campus. This is a little bit old. This was from spring 2017, before we had the data science major. So I'd expect kind of a bigger wedge for data science in the future. These big wedges come from economics and computer science. But basically, like, the slices of this pie correspond pretty well to the different majors that people declare on campus. So the distribution is skewed a little bit more in the technical direction versus what students study on campus. But we're drawing people in from a wide range of majors to take this course. And in fact, now it's a required course for majors that we didn't really expect. So civil engineering started requiring it, public health started requiring it as the way of getting an introductory statistics course, but also kind of learning a little bit about computational tools. Does anyone have these slides? Just click this button. Copy link address. I'm going to put it in here. Send it to everybody. Okay, so there's some, well, that didn't work at all.
John, there's a link to slides in the chat for people who need it from my message.
Okay, I'm trying to get people to click on a particular link. Don't click the one I just gave you, because it's wrong. But I don't know how to delete things from the chat. But I'm going to give you a different link. That one. Click that one. And if you wait a really long time, you might see something like this. I'll hang out for a bit and see if people have questions about the course. Well, those who want to can try to access this demo, and we'll look at some of the details. Any questions so far? So, what are we looking at? This is a snippet from one of the labs in the course, which is from like pretty late in the course when we talk about how to compute a confidence interval. They've heard a lecture on that, and now they're sitting in a lab room. They got 2 hours. They've got 25 other students in there, except for, not everyone shows up, so maybe 15 or so. They've got a TA in the room. They've usually got a couple of lab assistants in the room who have taken the course before. And these folks just kind of wander around and answer questions as they arise, but also push the students to ask questions by leaning over their shoulder and say, hey, what are you working on and how's it going? We do try to encourage students who are next to each other to actually talk to each other and work on the lab in pairs, but that doesn't always happen. When we first introduced estimation in the course, we talk about this problem, which is that let's say you have population of n elements that are labeled with serial numbers 1 through n, but you don't know what n is. And then you get a sample that's a uniform sample with replacement of these elements, and you're going to try to guess n. So you have some parameter you're trying to estimate, you have some sample, you can compute statistics on the sample. It's not obvious what statistics you compute in order to guess what your population size is. And there's no real data here, but it's kind of the simplest setup that we could come up with that illustrated the concepts we wanted to illustrate about estimation. Now, when we first introduced this in lecture, we just talk about estimators and then simulate the process of taking new samples from the population and seeing what happens with the estimate. But we don't really talk about kind of quantifying uncertainty until later in the course. And later in the course, talk about, well, if you're given a sample, could you somehow say something about how good your estimate is, or somehow quantify your uncertainty about the population parameter instead of just coming up with a point estimate. And we teach them about confidence intervals, but the only way we give them to compute a confidence interval is through resampling. And this is the lab where they kind of walk through that on their own for the first time. We try to keep the code minimal, but just enough that they can like play around with it if they want. Yeah, so they've seen this almost exactly the same thing in lecture. They're not doing it in lab, and then they'll go do it in homework later on. I'm gonna pause for a second, see if there's questions. Binder stall. Yeah, that's like that's pretty common. I did click on this and it worked this morning, but I think if many people are doing it at the same time, the service that provides this Jupyter Notebook interface might fail. If you look while it's loading at the logs, then you might see that it's doing something useful, or you might see that it's not doing something useful. But it might take a little while for this to load.
Can you talk about the decision not to have any real world context with this problem?
Yeah, good question. I think, you know, statistical inference is so hard to get your mind around the first time that we wanted something really simple. It was also important that we have a problem where we know the whole population so that you could check and see after you've like done some inference with the sample, did you actually kind of get the right answer or not? And so that you could repeat the sampling process over and over again. So, I think we ruled out any candidate where you kind of only have access to the sample and you don't know the population. And then we thought about like, oh, what are the cases where we could kind of simulate sampling from a real world population? And everything was a little bit more complicated than this one. So that's where we ended up.
So you rejected the German tank problem.
Tell me about German tanks.
In the Second World War, the German tanks were all numbered sequentially with IDs.
Okay, yes, I was told that they were German aircraft.
Oh, maybe, but I was told tanks.
But yes, in lecture we do talk about how German aircraft had sequential IDs, and this might be an estimation problem. But then we don't like try to find those data. Instead, we just kind of write it down like this.
Okay.
So yeah, so I'll have to check. Maybe it was tanks, and then we can figure out. Yeah. So we do try to present a scenario in which you might use this, but it's not something that pops up every day.
And of course, the disadvantage of having the scenario is that it can draw so much attention away from the abstraction that you're trying to get across that it makes students focus on the things that are not what you're trying to get.
Yeah, I think that's right. I mean, here we're trying to convince them that sometimes these techniques actually do what you expect, and that this is really like a method for making reliable conclusions under uncertainty. So we kind of want to keep things contrived for a little while.
Yeah.
Okay, so we're in a Jupyter Notebook. Did it load for anyone?
It loaded for me eventually.
Oh, okay.
Yeah, it's loading for me too.
It's possible. Okay, so if you haven't used the environment before, there are keyboard shortcuts that I'll use, but there's also ways to execute the code in a cell. So you can, when it loads for you, you'll probably see a toolbar, and kind of typical thing to do would be to run the cell. That means that all the code here is executed. But I'm going to hide my toolbar so that there's more stuff on the screen. So the way in which we present the textbook, the lectures, the labs, and the homework assignments is all the same. There are all these notebooks, which are a mix of kind of free response questions where they have to think about what they're doing and write it down, and then coding questions where they have to execute something. So we try to keep them away from just like writing down the details of a technique, and instead make sure they have the context of knowing why they're doing whatever they're doing by these various prompts. And this particular version we pulled from our edX course called Data 8.2x. So that's why it says like check your answer by posting on the discussion forum. But the in-class version would say check your answer with the person next to you, because there would be someone next to you. Okay. And then the way we run this particular lab is that we give them a sample. We don't tell them what n is. And at this point in the course, they know something about how to work with this object, which is one column table where, if they want to show the whole thing so they can see all the values, they know how to do that. If they want to, see if they're unique, then they know how to do that too. And so this is showing the count of each value. You can see like, oh, there are a bunch of things happen to only show up once. And here in sorted order, they can see they range from 21 up to 135. And yeah, the earlier part of the course, hopefully ingrained in them some discipline about when given a table to take a look at it and try to figure out what's going on there. So they might do that. We, what is this thing anyway? We did build for them a module, like a library for working with tables that's different from the standard tool set in Python, because the standard tool set requires you to know a lot about the programming language in order to get anything done. Sorry, recovering from a cold. And some students are irritated that we've given them something that's not like a standard tool. But I have a hunch they'd be more irritated if they had to learn pandas from day one, because they'd have to like understand all these notions like slicing and Boolean arrays and stuff like that, it just like would overload students even more than they're already overloaded. So let's see what I can point you to. If you want to know what the library looks like, here's like a little tutorial. And the basic gist is, you could build a table from scratch, although almost always it's loaded from a CSV file. And then all of the operations that you would expect in a SQL select statement, like selecting columns or filtering the rows with a where clause or joining or grouping, they all have methods with the corresponding name on the table. And we've tried to make it consistent with SQL whenever possible. I think that's probably the most common language that people use to manipulate tables, so they might as well learn the right verbs. But it's using Python syntax. So see if I can get anything useful for you. Oh, this tutorial is terrible. Oh, I should fix this. Anyway, I can give you a sense live here. Like if you want to say where the serial number are above 50, then that would give you a new table with just a subset of the rows. If we had multiple columns, then you could select particular columns. But then there's like join Why didn't it appear? It appeared very briefly. I make it appear down there. Oh, I can't. I don't know why the help is not appearing, but I guess I can do it the hard way. Help. The join method basically says like observations.join and then pick some other label. Pick the label of the column that you're joining on and then give it the other table. And it will do its best to find an inner join. But it doesn't really give you any options to compute a left join or a full cross product or anything like that. It's just like the simplest, most commonly used version of different operations, with the expectation that if students want to do something more sophisticated, then they'll learn some other library after the course ends. But this is nicer than I think what would happen in Pandas, where you'd have to learn how to write observations. Then you have to explain why you're using square brackets instead of parentheses, and then you'd have to type operations again, and then you'd have to get the serial number, and then you'd have to build a Boolean array. And, you know, so anything you could do in our table library, you could do in the standard tool, except the syntax just gets more complicated. See if you have any questions.
There's a question from the chat asking, did you write down the argument for the data science module instead of pandas? Can't you get away with pandas, the good parts, if you see what I mean? And then there's a couple other comments after that. Do you want me to read it?
Yeah, let me see. Why did we reject pandas? The indexing is kind of complicated. So the fact that that rows have an index to that's not just their position means that as soon as you sort, you've got this like extra column of numbers that's not a column of numbers, instead it's an index. And if you don't know anything about what data types are, then it can get very confusing to figure out whether you're referring to a data frame or a series or an index, and how you like put an index back into a data frame as a column. As soon as students have seen any kind of like object-oriented programming, then this is all straightforward and fine. But if they haven't, then I think the expectation that Pandas puts on users about what they understand about their programming environment is pretty high. The filtering rows problem is really a problem. Like, why do you have to say observations twice, once to build the Boolean array that tells you which rows to select, and another time to tell you what table to select it from? It's just something that takes a lot of effort to explain to students. So that was an issue. And then like when students read the Pandas documentation, they don't just see the good parts, they kind of see it all. And I think that might be overwhelming to them. So we see, like in Data 100, we introduced Pandas and we worked with it. We see students kind of struggling with it there, because it is a bit of an esoteric interface to a table. It's really flexible and really powerful, but at the same time, like once you start digging into the objects you have to kind of like know something about object-oriented programming in order to get what you want. We just kind of couldn't make it work. I'm sure it could be done, but it would be the right choice if we asked them to take a programming course before they ever got into Data 8. I think it's a tough choice if you're trying to teach them programming at the same time.
Great.
Okay. Okay, define a function named plot serial numbers to make a histogram of any table of serial numbers. So we don't spend any time in this course telling students how to format their figures. That's like kind of the details of how to make a good visualization is mostly saved for another course. And instead, this course is about which visualization is appropriate and how to interpret it. So, you know, you take your table, you draw a histogram of a particular column. It's something they know how to do. And we do spend a fair amount of data 8 in learning how to interpret histograms because it's just like a difficult concept for students to grasp. And we try to keep pushing them on it. So now we try to follow it up with the question of like, look at this histogram. What do you know about n that you're trying to estimate? Why are all the bars about the same height? Probably this question should say, why are they different heights as well? But we'd expect students to do some reflection about the data visualization they're looking at. Okay, so then we say one way to estimate n is to take twice the mean of the serial numbers we observe. And so write that estimator as a function, and then they'd return the mean of the numbers that they observe. I did it wrong. It says take twice the mean, and I've done just the mean. We've got this like a system for checking their work, where we run test cases against the current environment that they're in, so that when they fix things and then run the test again, they kind of know they're on the right track. And I think this is important for any kind of scripted exercise, because if they're kind of like late in the game and they don't get the result that they expect, as long as they have all these checks along the way, they'll have some notion of where they screwed up. But if they don't have these checks along the way, then they kind of don't know where to look. And students at this course certainly don't have the discipline to check their own work because they just learned how to program, 2 weeks ago. So helping them do that for them, I think, is probably the right call. This is me pausing for questions. Are people doing this alongside, or did Binder just wipe out and so you're watching me do it?
I've been following along, actually.
I started doing it, and then my attention was too divided.
Okay. Yes, well, you can do it later, I guess. I just don't know if it's helpful, because anyway, any comments now about whether you want me to go faster, slower, skip stuff, go back to high-level descriptions, talk more about technology, whatever you want me to do is fine. Because I could march my way through this document, but you could probably guess where it's heading, so I'm not sure that it's worthwhile to do that. So any questions or comments about where to go from now?
Can I ask a question?
Yeah, sure.
So, yeah, I mean, I guess my question mainly is how can we help you? And I guess what do you think we should do? So, I mean, it sounds like we need to quite carefully think about the kind of ways that we're applying this course. So, for example, you were saying that you should definitely have sort of 2-hour practicals. You definitely have homework, should be graded, I guess. I mean, these are all things which would be very useful to sort of have recorded somewhere, sort of like a body of practice about what works and what doesn't, what you can get away with, how that might vary according to your student's background and so on. Whether it's worth trying to split the class into different streams, that kind of thing.
Yeah, I was hoping what would happen is like all the instructors who were trying to implement this would get together in an online forum and share what was working and what didn't. I'm not sure that that's really happened. We did identify someone here on campus who said they would organize such a thing, but I don't know that it's worked. So yeah, I mean, it's a course with a lot of moving parts and a lot of things that can go wrong. And of course, like few people have taught anything like it before because it's a new discipline. So we probably all do need to kind of work together and communicate with each other a lot. A big README file on how to run the course would probably be a good start, but I wouldn't even know. I do a lousy job of writing it down without some kind of conversation about what you need to know. So yeah, so maybe that's the right thing to do, is set up a forum where we can all talk to each other about what's going right and what's going wrong, with the expectation that things will go wrong and you should ask about it because maybe there's a fix.
And how many people are running something related to that, to the data 8?
Oh, I wish I knew the answer. I know that I didn't know about you. I know Yale's running it now, and San Diego is running it now. Then I've been in contact with like individual instructors who've been running it on a pretty small scale. And they've been kind of changing a lot as they go. And but I don't have the complete list, which makes me nervous because I outsourced it to a wonderful fellow named Anthony Swen here at Berkeley, who's trying to kind of coordinate among instructors. But I'm not sure that the setup works because he rarely asks me to communicate with anybody. And it sounds like there might be some value in me communicating with the people trying to run this. And so we should probably set that up. When we did the kind of interest form of how many people wanted to run something like this, I mean, it was kind of in the 30 to 40 range. So there may actually be versions of this running at lots of different colleges and universities at the same time right now, but in a very distributed and unfortunately diffuse fashion.
John, there were a couple questions from the chat that are interesting. First, just some confirmation that people were working in Binder and having a good time working with the problems. There were two questions about grading. I think I'm going to read them back to back and then maybe let you speak to both. The first is, can you explain more about how to implement the grader system from gopher.ok import check is the first comment. And then the second is, last I saw there were projects. How do you grade them and who grades them? And also, why not use Google Collaboratory instead of Binder or Jupyter Notebook? And you example.
Well, the last one's easiest. I don't think there's like a good case to use or not use Google Collaboratory. It seems pretty great. Jupyter seems pretty great too. It's been nice for us to have some control over exactly what's installed for each of our students and to make sure that like we can have a link. Well, let me just show you. The course website looks like this, and they click on this link and it loads their notebook, kind of like the Binder link, except for it loads it in an environment where we have administrative access, so that if they do something wrong, we can go in and fix it for them. So there's been some advantages at our scale for trying to use Jupyter Notebook, the kind of Jupyter Hub infrastructure, because we have a system administrator who's willing to run it. If you don't have so many students, you don't have the right people to run that, then maybe the Google Collaboratory is exactly the right thing to use. Grading. Oh man, grading's a bear. So here's what we do. When we tried to like release these course materials to the world, we were satisfied with how the lectures look and how the textbooks look and how the assignments look. But the things we didn't release well, because they're more experimental, are the publishing pipeline, where we don't actually write this notebook. Instead, we write a notebook that has solutions in it, and there's like a script that removes all the solutions and turns the checks into, and like adds this little snippet of code. And that, until the last few weeks, has not been public because it was just like a nasty mess of make files that I didn't understand, so I didn't even know how to release it. And then the second part is grading. So, which was also kind of problematic. So let me tell you how it's worked here and how we're trying to set other people up to follow that same path, and how far we have left to go before you can really do that. So the way it works here is that every notebook has two components. It's got the questions that can be graded automatically, and it's got the questions that need a human to read. The pipeline that seems to work okay for us, but wasn't really in place until recently, is that for each notebook, we export a subset of it as a PDF where the subset only contains the answers to the questions that have kind of free response. So they're answered with text, or they're answered with a graph or something like that. And the reason we generate a PDF is that we use a tool called Gradescope, which maybe you've seen, which is just like a really nice interface for writing down the rubric by which an assignment is graded, and lets many people grade it together in a way that tends to be fairly consistent. But the downside is the Gradescope only ingests PDFs, so we need to like generate a PDF from the notebook to do that. Just the standard file download as PDF has been problematic for us because the question 7 always ends up in a different place depending on how much other stuff is in the notebook. And the Gradescope interface is really built around having PDFs where the same answer to the same question shows up in the same place in the same page every time. So, so we have like a little snippet of code here called JAssign, which has a to-PDF trick that tries to like put the answers from different students on the same page of the PDF. And that works pretty well. Okay, so there's like some little piece of technology that helps us with manual grading. Then the actual process is students submit. They submit a notebook. We take a notebook. We auto-grade the parts that we can auto-grade. We generate a PDF from the notebook. We ship it off to this other external website called Gradescope. And then we have a team of readers and tutors that do all the grading. Oh, that was a long answer. Now, now I've really been pushing my team to open source these tools instead of just having them like buried in make files within private repositories, but we haven't done so well at that. So what we do have is that there's a service that we run that you can submit notebooks to. And it allows the instructors to see the students' work, it allows the students to see the students' work, and it serves as a grade book. So the scores for the students' work get recorded on this website, and then you can like export it as a CSV at the end of the day. And there's like some Canvas integration as well, but I have no idea if it works, because this was all built by students who have now graduated, which makes me a little nervous. But it's a wonderful piece of software, and the folks that graduated still seem to help us out when things break. So we haven't given up on it completely. But this doesn't actually do the automatic grading. Instead, there needs to be some other component that checks whether the student answers are correct automatically by running these tests. And there's like a separate auto grading service, which, oh, I guess is, I forgot where it is. There it is. Okay, well, I'm not going to try to show it to you because it basically doesn't have a web front end. It's like a bunch of scripts. Oh, there's a documentation page. I think I can show you that. So, okpi.org. Documentation. Okay, and then there's an autograder. Okay, so there's like a little bit of description of some service that was originally just designed for Python source files and was then retrofitted in a hurry to run on notebooks. And my TAs seem to always get it to work, but people in external organizations like other universities seem to have a hard time getting it to work. And since I don't personally know how it works, I can rarely come save the day, which has been a constant source of frustration for everybody involved, because it would be nice if like students just submitted their work and it automatically got scored for them and they didn't have to think about it anymore. It was problematic enough around here that we've actually have like multiple different versions of autograders. We have one for the edX course, which is this thing called Gopher. We've got one for Data 8, which is called OK. And then there's a separate autograder backend for Data 100. And we just built it because the old one didn't work. So if you're wondering whether there's like a battle-tested solution for running all of the tests against all of the student notebooks, I'd say the answer is no. And if you're wondering whether there's a battle-tested solution for manually grading their work, I'd say the answer is this combination of this little script called JAssign plus Gradescope works pretty darn well for us. Another great option is something called NB Grader, which has a different format for authoring the tests, but it's pretty similar. So I'm sure if you had an assignment using one format, you could convert it to this other assignment format pretty quickly. And this we have tried extensively. It requires you to be running your own Jupyter Hub in order to get it to work. It's quite a clever piece of software. It doesn't have the sophisticated manual grading tools that you see in Gradescope built into this tool, because this is like a special purpose thing that's only for grading Jupyter notebooks. And so you can't like design a rubric and then rescore the rubric and look at statistics of who did what. And when you have many people grading it, it's harder to divide up the work. So we've moved away from it just because it's not really set up for a course with 1,000 students. But I think it's a more reliable piece of software at this point.
So it seems like auto-grading is a data science problem unto itself.
It is. And it's one that, that people have tried, that very talented people around here have tried to solve and have kind of come up short because it's there's just so much complexity in terms of what students might turn in and what assignments might need to get built and kind of like what constraints are imposed when they're being scored. It's a little bit of a messy thing.
Thank you for answering these questions, John. These are great. And thank you everybody for your comments too. It sounds to me like there's a lot of discussion going on about grading in our chat room.
Maybe I can catch up a little bit.
What's that?
Yeah, I'll try to catch up.
All right. Let's see. So going back to the tab where you were showing the different assignments, somebody asked at some point, do you have checks on answers during the midterm?
Yeah, so we still run our midterms on pencil and paper.
Uh-huh.
And we grade our programming questions by hand. So there's always questions like, you have these two tables and you want to know, like the average time for a bicycle trip in the winter or something like that. And so like what Python expression would compute that number for you? We've had no problem at all trying to grade those by hand as long as we structure the prompt such that there's only so many answers the student can give. So I guess I'm a little bit averse to multiple choice because I just don't know how to write good. I don't personally know how to write good multiple choice questions. So I do more fill in the blank. But maybe if I dig around, I can show you an example of the kinds of questions we ask. Bingo. Oh, but you probably can't see it. Hold on. We'll get you there. You might be staring at an exam. So this has been like a really reliable way for us to write questions that are easy to grade, seem to assess basically the right thing, and give students plenty of freedom to get it wrong. But at the same time, it's easy to identify the right answer, which is like, here's some table, write down a Python expression that tells you the name of the third highest paid faculty member or whatever it is. And so we don't try to automate the scoring of exams because it's pretty fast. I mean, we just get them all done in a day with our teaching team. And of course, the exam isn't all programming. There's a fair amount of like, can you understand what's going on in this histogram? And this is a midterm, so they've only really seen intro to probability, a lot of visualizations, and then they just saw hypothesis testing. So they kind of like fill in the interpretation of the hypothesis test.
So backing up from this, thinking about assessing students in a data science course, can you talk about what you're looking for in the course that isn't just programming and isn't just statistics, that we might say, well, this is data science, and this is the part that makes this course different than intro to those other courses, and how you gauge whether students are getting that kind of insight into the field?
Yeah, I'd say that, Data 8, which is this freshman level course, really doesn't try to push beyond the kind of convex hull of computer science and statistics much. And that happens in Data 100. So what happens in Data 100 is you say kind of like, how does the data science lifecycle differ from the statistics lifecycle? Well, in data science, no one hands you the table and says, please do your analysis and report back your analysis. We'll interpret it and your findings. Instead, what happens, and of course, in like statistics, this doesn't happen because there's this whole kind of field of study design. But in the data science course in Data 100, we talk about how sometimes you have the opportunity to do a study design, but sometimes you're kind of just working with data that may be available to you because it was already collected, but it may not be the data that you would have collected if you were running the process. And so there's kind of like a large amount of understanding the context in which the data were generated, finding out how to manipulate, fairly complicated, databases and log files and things like that in order to build data in rectangular format that could actually be useful. And then kind of visualization techniques that handle high dimensions and large data sets at the same time. Now, I feel like most statisticians would say, well, that's all within the realm of statistics. And I hope that's true. I mean, I think statistics as a discipline is very broad. And what's different about data science is that you kind of focus on computation as your primary tool for solving the same kinds of questions that you were trying to solve before. But kind of the forefront of data science, of statistics as it moves into like even more data-driven field rather than so much about modeling, is that you spend even more effort kind of formulating what questions and what analyses are even worth doing to get at the goals of whatever analysis you're trying to perform. What data are available? How do you understand those data using computation as a way of kind of exploring and cleaning the data? And so like at the end of the day, you're still just doing statistics, right? You're still just trying to draw robust conclusions from incomplete information, but your activity is a little bit different because of the way in which computation is used.
So would you say that a student finishing the Data 8 course still has figured out or has a good idea of what data science, what it would be like to choose a data science major, or are they really only going to get that in Data 100?
Well, there's certainly parts of the major that they're not exposed to.
Yeah, that's what.
The theory they're not exposed to. There are a lot of problems where in Data 8, you can do the computational version, and then you could also probably just do it by hand if you wanted to, because the data sets are only so large. But you know, that rarely happens in the real world, and so you have to like have a better understanding of the results of your computation without being able to check your work by hand. And that kind of level of sophistication with programming only comes after you've taken programming courses. I don't think that's something that students are really set up for at Data 8. So, and then like the relationship between mathematics and data analysis just isn't in Data 8 either. So there's certainly parts of the program that have yet to be introduced when they get to the end of the first course.
Wonderful.
Maybe I'll talk a little bit more about the second course. This is the course for people who are going to major or minor in data science. They have strong fundamentals, meaning they've taken calculus, they've taken linear algebra, they've been exposed to probability somewhere along the line. They've taken Data 8, so they know something about statistical inference. And what are they going to learn here? Well, they're going to learn something about what's the data science life cycle looks like. We go deep into exploratory data analysis in order to try to understand a data set that, that you didn't get to build by designing the study. And then, I wonder if I'm sharing my screen or not. I think I am.
Yeah, you're sharing your screen.
Okay. And then how exploratory data analysis leads to kind of data cleaning. We talk about imputing missing values or other ways of managing them and trying to get people out of the habit of just pretending that isn't an issue. And then I talk about how, like, as you're doing exploratory data analysis, that's sometimes when the hypothesis that you want to test comes out, because now you know kind of what questions you can ask in a precise way. Whereas if you don't know what data you have available to you and kind of what's its scope and what's its granularity, then you don't really know in advance what hypotheses you can test or or what you can hope to estimate. So this kind of story about how most data analysis, when using data sets that you didn't create because they were created by an organization or by some process in the world that you didn't design, involves a lot of exploration in addition to kind of just going ahead and answering questions or making predictions. And then we talk a lot about kind of high dimensional versions of what was exposed to them in Data 8. So Data 8, we only do a simple linear regression in 2 dimensions, so 1-dimensional input. Whereas in Data 100, we spent a while on multiple regression. And then we talk about logistic regression. We do expect them to be able to understand, like, that you could try to optimize the regularized logistic regression objective function using gradient descent. And that's not something that we would ever try to even touch on in Data 8. But it's still the case that we're kind of like finding real world data sets and then we're mucking around with them. And in this one, I guess we find data sets in different formats. We find data sets with kind of that are less complete. And we almost always start with the raw files as they were discovered on the web or presented in a scientific paper or whatever, as opposed to a cleaned up version that's presented to the students. The instructors, so I'm teaching this course, but I didn't build this course. This was mostly built by Joey Gonzalez, Joe Hellerstein, Deb Nolan, with input from Bin Yu and Fernando Perez. They wrote down the course goals. So prepare students for advanced Berkeley courses in data management, machine learning, and statistics, by providing the necessary foundation and context. So in a sense, this is an introductory course. It's just an introductory course for students who already know something about statistics and they have some mathematical foundation and some programming foundation. But we'd like it to be the case that other courses were built on top of this, you know, and would be willing to rely on the fact that students know what they're talking about when someone says like, oh, what's the dimensionality of this data, or are doing some interpretation of multiple regression or whatever they might do in a future course. A goal is to enable students to start careers as data scientists. So I think this is something we've struggled with, but we are interested in making sure people are set up to go use this in the real world, instead of just focusing on kind of the academic implications of what we're teaching. So this is not just designed to send people to grad school in more data science, but instead we do want to kind of collect input from industrial partners and figure out what people actually do out there in the world, and build the course around that. And empower students to apply computational and inferential thinking to address real world problems. Yeah, there's an optional path through the course where you pick your own data set and you do something interesting with it. And we'd like students to take that path. Not everybody's really ready to do it by the end of this course. But it's certainly a goal to get students to follow that path. Let's do a little, let's take a glance at a lab. I paste in a link. Oh, I lost the chat. Come back, chat. There you are. I'm going to try to catch up on the chat too. Oh, the grading software looks awesome, but my institution would go berserk if I shared student grade info with an organization from outside campus. Yeah. Well, the reason we try to write these as open source software is you could host them internally. Gradescope not, but the OKPy that is basically our grade book and assignment repository, you could host yourself if you want to. Oh, there was a question about will these courses continue to use okpy.org. Yeah, we're going to continue to use that. We did go through the process of evaluating a bunch of alternatives, and we picked that one again. So I don't think we'll reevaluate anytime soon. But we did change OKPy recently so that you can connect any external autograder you want to it. And so there's like a proliferation of the server-side autograders that actually assign the scores, but OKPy will still remain the place where scores are tracked. And we don't just track scores there, but we track like extensions of, you know, who's going to turn things in late and who's partners with whom and all this kind of stuff that might show up in a course like this. That'll all continue to happen through OKPy. Will you plan to release Data 8 class videos that's newer than the fall 2016? Yes. Let me tell you where to find them. You're just going to have to deal with me sitting here searching the web for a second, but it might work out for you. So we created a set of studio lecture videos for our edX course that covers all the material in Data 8. And although these are not nicely packaged for you currently, you can go fish them out of the edX course anytime you want. It's taking its sweet time. Everything's free, you know, there's like a way to pay if you really want to, but you don't need to pay. And, oh, see, it does say it's free. Okay, good. There's now like a self-paced edX course which you can enroll in, and you'll find YouTube videos that we created last year that were recorded in a studio, and it was 3 of us that did it together. Myself, Ania Adhikari, and David Wagner. The 3 of us have been kind of trading off teaching this course for the last couple of years. And I think the videos came out pretty well. So I guess I'm not enrolled, so I'm not gonna make you watch me enroll. But if you enroll in the course, you can find the links to all the videos. And I think if what you really wanted was like a playlist that gave you all the videos without you having to dig them out of the edX course, then you could just send me an email, and I'll bet we could provide such a list to you then you have an updated set of videos for data 8. Okay, maybe some people clicked on this link to load a Data 100 lab. So this is just like an example of lab from the course. So we still use the same or similar grading infrastructure to check their work, but now we're not using the data science module, which we built for data 8. Instead, we're just using standard tools. And I guess this data set is actually loaded locally, but for most data sets in the course, we just point to their original location on the web, as opposed to trying to host our own version, so the students can kind of like read the contextual information that's there. I'm not sure why that didn't happen in this lab. Sorry, I don't actually create the lab, so I'm kind of working through this for one of the first times, just like you are. And I'll just skim as we go. We do try to tell people about, you know, what a zip file is and how to work with paths and how to discover that there's data inside of a file format that they might find on the web. And the goal there is basically just to make sure that when they go off and find their own data set, they're not paralyzed by having had any particular part of the process done for them before. Instead, we walk them through all of the steps. What you're seeing here is a data set from Berkeley of the police department's call for service over some time range, where each row documents a call. So this was like some legend information about what happened. There's some information about where it happened, and then the city and the state that it happened in, which is always Berkeley. And the lab, this is an early lab. So week 3 means they're doing visualization, data cleaning, and they're still just kind of learning the pandas library. So we sort of have them walk through, try to understand what's in this data set, yeah, here we're just showing them some of the like example calls that you can make. So describe goes through all the numeric columns and tells you about their statistics. And then we give them some question to work through. So before we go through the fields to see their meetings, this cell below will verify that all the events happened in Berkeley. So we count up where they happened, and there's 3,788 rows in this data set, and they all happened in Berkeley, California. Okay, then we start asking them questions. So let's see what the question is. Above, it seems like offense is more specific than CV legend. Because theft felony over 950 is a little bit more specific than larceny. And so this says, like, figure out how many subcategories are by building a multi-index series where the data is first indexed by CV legend and then by offense, and then take a look at the size of each one. So then you like go through and write some expression that computes this series. Excuse me. So what's going on here? Did I do everything I need to do in order to get this to run? Doesn't look like it. Oh, sorry. Okay, so here's calls. So we'd want to like group by first CV legend and then offense. So now we have this group by object, and then we have to figure out how to aggregate it. I think that's what they're looking for. So we can just assign it and run some tests. Okay, so, and then we can actually look at it, calls by CV legend and offense, and we can see like larceny is like a distribution over different kinds of theft. So, I mean, this is the kind of work that they're doing in Data 100. It's actually quite similar to what they did in Data 8, except for that they're working with the original data files. They might write more complicated pieces of code in order to like unpack a zip file and find the components. They're using standard tools, and they're working with data sets that tend to be a little bit messy. In the interest of time, I think I will not march through more of this. I did provide, like if you go back one level, you'll see that there's a solution that I tried to throw together right before we started this webinar. But I wanted to point out one particular thing. So if you poke around in this data set, you'll see that there's like a day that the service call was made, and there's a time that the service call was made. And so, you know, you can look and see like, oh, what day of the week did people tend to call the police on? And there's some like interesting distribution there that's not entirely flat. But then if you pick particular types of calls, like noise violation calls, then they are concentrated on Thursday, Friday, and Saturday, which I guess is when people are partying in Berkeley. I didn't know people partied that much on Thursday. I guess I should make stuff due on Friday from now on. And then there's like an interesting bit where if you look at the time that fraud calls are made, you see this kind of distribution where most of the calls are made in the day, and then a few of them are made at night. And there's like this big spike at 0. And we're asking students to reflect on like, what's going on here? Is it that people always call in to report fraud at midnight? Or is it that someone went in and filled in missing values with a 0? So this kind of like a reflection on the data set is an important part of what we'd hope they'd get out of working with data in Data 100. Oh no, no module named Seaborn. Sorry about that. I guess I'll have to update the requirements. I'm going to do that now. While you all ask more questions. Anyone? Questions? Comments? For those of you who want this to actually work, you could actually just add pip install Seaborn to the top, and then it should install it on Binder, and then maybe things will run.
A couple other questions are trickling in. One person asked, is this due at the end of a 2-hour lab?
This is a 1-hour lab where students don't always finish. So the way we run Data 100 is to have 1 hour a week of lab, but with the expectation that maybe some people are going to have to finish it on their own time. And then there's an hour a week of discussion, and the discussion tends to talk about the kind of more analytical aspects of the course. Basically like review the math, but also review the like conceptual questions around data visualization. Yeah, I guess it's not true that the discussion is all about math. There's a lot of variety in what happens in discussion, but the point is that people aren't working through exercises on a computer. Instead, they're kind of working through exercises on a worksheet.
So you have a huge enrollment. What's been the response of students? It must be pretty positive if it's building ever greater numbers of students enrolling.
Yeah, I think Well, I haven't taught the course before, so I don't have access to the survey results, but what I've seen from some of their summaries is the students do enjoy this course. For many students, this Data 100 is what they were looking for when they started taking data science courses. If they started out with a bit of background, they had taken statistics and a little bit of programming before, then Data 8 can be a little slow for them, and doesn't feel like it's kind of giving them superpowers to analyze data. Whereas in Data 100, they're feeling like, oh yeah, now I understand what to do when I find a new data set. And so that's been pretty rewarding to see students get excited about it for that reason. Yeah, and we've seen quite a bit of interest from graduate students across campus. I mean, like, 50 or 60 are enrolled now. I think closer to 100 were enrolled in the fall. It just like depends. There's a little bit of seasonal variation in when students would take this course. But yeah, there's certainly interest in people trying to figure out how to fit data science into their home discipline. Okay, what else was I going to tell you? This is probability course. You should definitely check it out. I'm not going to do a demo, but I will tell you a little bit about it in case you're teaching probability to students who might otherwise take these other courses. Annie and her team have put together just a great textbook that's free, online, goes through all the standard theory that you'd see in an upper division probability course. She taught our upper division probability course for many years, and so kept everything, but adds a little bit here and there to help bridge the process of students moving from just programming courses into machine learning courses, where they often struggle a little bit with the math. And so she tries to kind of like build up a better foundation there. And then she tries to illustrate probability theory with some sampling exercises. And so there's a programming component to this course. It's not primary in any way. I mean, the goal of the course is more kind of theoretical analysis, and most of the work is just standard problem sets. But students do work through some computational exercises using the similar tools to what they saw in Data 8. And she's pretty sure that helps them understand what's going on when taking expectations of something. If you could simulate an estimate for it, then maybe that's gives you some intuition about what you're trying to compute. So these were Annie's observations that she sent me. She said, Data 8 background provides extensive experience with sampling variability and the motivation to delve deeper. So it gets students more excited about learning probability theory because they know sampling happens, but they don't really know how to analyze it. And she thinks that computation and visualization help reinforce the math and make it more concrete. And then patterns observed by computation provide motivation for mathematical justification along with appreciation of the math. So the idea is, if you want to learn probability, take Data 8 first, do some sampling, look at some real data, and then now you have a reason to study probability theory. And she thinks the students solve more substantive problems than they could have on just pen and paper when they have access to computers. All right, I ran out of stuff to say. I'll hang out for another couple of minutes, see if people have questions or comments.
For those of you who don't know, we do end at 10:50. It's 10:41 right now, so this is a great time for questions and comments if you have any. You can go ahead and turn on your microphones if you have any, or post them in the chat, whichever works for you best.
Oh, should ethics be included in the course? Yeah, ethical and context issues show up in both Data 8 and Data 100. In Data 8, we did a good job, I think, of kind of applying them uniformly across the semester. And Data 100, it's been more concentrated in like a particular guest lecture here and there without a good job of exposing students kind of every week to the social implications of what they're doing. And so it's going to take some time in order to kind of change that. But we have a group working on it now. So we're basically just going through the labs and assignments and looking for, could we swap out the data set we're using with another data set that illustrates the same technical concepts, but also raises some new interesting social questions, and then talk about those social questions. But because it's on top of everyone's mind, like what does data collection mean for privacy? What does who owns data, and who should have access to it, and what responsibilities do those have who have access to sensitive data, and how do they kind of keep track of those responsibilities? So I think the goal is to put it in everywhere in Data 8, put it everywhere in Data 100, and to have a dedicated course to it. And by the end, students might have the right amount of exposure to thinking about the consequences of their work. Students these days seem to be really excited about those topics. They seem to be predisposed to engage in kind of the questions of social implications. So it's not really us forcing them through these ideas, but instead them happily addressing them as they come up. Of course, students are different, so that's a broad generalization from a population with a high variability. But for the most part, it's worked out pretty well to address ethical topics as we go.
So, John, thinking about the high school students, what would you like to see more of taught at the pre-college level that would be a good preparation for moving into the data science major, or even just taking the Data 8 course?
Well, I mean, Data 8 would be a lot easier to teach here and elsewhere if the programming component had been covered before.
Sure.
It's also somewhat easier to teach if students have seen some version of the statistics before, but they spend a lot of time figuring out, like, how does my way of computing a confidence interval line up with this way of computing a confidence interval, and when should I use one and when should I use the other? They kind of get focused on the details instead of making sure they know how to interpret the result. So it's not always a huge benefit to have taken like AP stats before. Sometimes it's great, sometimes it's not. Really depends on how it was taught, I guess. But yeah, like some programming background coming in would certainly be helpful. And yeah, and I guess we don't at the college level know what to rely on in terms of students' prior experience, because it just seems so varied, like what they've done with data before and what they understand about what a distribution is. It just seems really varied. So of course, if there was like more of like a standard foundation for talking about distributions, actually a standard foundation in probability would help. And we kind of knew at the college level what high schoolers were learning, and they were all kind of learning similar stuff, and that would make our lives easier, but that's probably a tall order.
So I keep thinking that at the pre-college level, if students had more experiences being immersed in data exploration and analysis and visualization, regardless of what the concepts being taught were, that would be helpful.
Yeah, that sounds pretty plausible. Like you take the average of different groups and you look at them, like, what does that mean? You don't really need to know a whole lot of conceptual material in order to try to interpret summaries, like summary statistics, but it's really hard because if you haven't kind of worked with data sets and tried to summarize them before, then you just like, some students will react by being like, oh, here's a bunch of numbers and this one's higher and that one's lower, but they don't necessarily learn anything about the population that's described by the data set. So that seems very plausible, that just having some experience trying to draw conclusions, even if they don't have any like inferential tools to do it with, would help.
Nice.
This has been an amazing overview.
Yeah.
Well, thanks everyone for following along. The links are out there, so feel free to share them around. I'll leave this repository up, DSE Cal Data Science, which, let's see if I can turn it on, which has links to the slides and the demos, and this actually hosts all the demos. If you want to find the notebooks, then there's like the one without the answers, there's one with the answers, and then these links will load them into Binder for you.
Well, fantastic. I'm going to go ahead and post these in chat too while I wrap things up for us. So those of you who need the links, let me go ahead and post that here. And thank you all very much for a wonderful webinar. I'm just going to go ahead and share my screen. I think I need to, John, if you could release your screen, then I'll go ahead and do.
He did.
Oh, excellent. There we go.
It's one step ahead of you.
One step ahead of me. Thank you. Okay. Well, again, I had a really terrific time on this webinar. Thank you, John. Thank you, Bill. Thank you, everybody, for joining us today. If we did not get to your question or you'd like to leave additional questions, as John mentioned, you can email us or post on Twitter. We will respond to you as soon as we can. We had a lot of great interaction. I'm really grateful to all of you for making such rich discussion happen, especially the grading questions. Those were really fun to discuss. We'll send you a link to the recorded sessions shortly. And if you enjoyed this webinar and you'd like to attend future data science education webinars, our next webinar will be March 13th with Randy Kochevar, who is a senior research scientist and the director of EDC's Ocean of Data Institute. You can sign up for Randy's webinar and future webinars at concord.org/meetup. You can stay connected with us on Twitter at CodeAppDataSci. If you use the hashtag DataSci and to tweet us any additional questions or resources, we'll be sure to respond to you. Please feel free to visit our website, codeapp.concord.org, to connect with us as well. Everybody, thank you again very much, and I wish you a great rest of the week. Thank you again, John.
Thanks so much, John.
Bye, folks.